Wow, a square. That's crazy. Did you know the way that a square rolls, as it turns, the shape it makes is known as a cyclogon? Pretty interesting. Now, squares aren't the only ones that can do that, right? Oh my, I dappered myself. You can also do it with pretty much any shape, you know? You can do it with a pentagon, you can do it with a hexagon, and all of these create pretty much more and more bumps, right? Until it creates that. Once it gets to a circle, that's called a cycloid. Cut it. Are you going? Oh, okay. Why did I tell you about cyclogons? I don't know, you just have to figure it out. Basically, there's also this other problem scientists have been trying to figure out for years. How to get from one tip of a triangle to the other the fastest way possible. This is called the brachistochrone problem. I don't know how to spell it, but it's a pretty cool theory. Now, this one philosopher, he had a pretty good idea. He thought that it was just part of a circle, right? There's your circle. But it was close, but not quite exact. Alright, so let's just do a little thought problem, right? So let's say you're here and you want to get to your ball, alright? You're in the water, you know, you're just playing along, but then your ball, it gets lost in the grass. So let's say you want to find the quickest route to get from here to your ball. Now, you could go just straight that way, right? However, you'd have to wade through water, which is going to slow you down quite a lot. So let's say in the water, you're a lot slower, whereas on the grass, you're a lot faster. This is going to have you going through the water, you're going to be pretty slow. If you go straight this way, hey, you're probably a little bit faster. But then, if you go this way, that's the fastest. And some guy came up with the idea that if you take the angles and you take the sine of those angles in ratio with how fast you are on each pieces of water and grass in this situation, you take those angles, the ratio should be equal. This is what's called Snell's law. Light always follows Snell's law. That's very interesting because have you ever noticed when you look at a glass of water, you stick something in there, and then you look at it from the side and it's like, it's a little off. That's because light travels slower in water than it does in air. So it refracts a little bit differently. So one very smart mathematician decided, what if he lined up little clear bars that light travels through at different rates? Well, it starts to make a curve. And this curve, following Snell's law, is what is now known as the brachistochrone curve. So, this brachistochrone curve, this mathematician found out, hey, you know what that looks like? That looks like a cycloid. The path at which a circle follows from one end to the other when you track a point on the side. We just talked about that. Wow. Brachistochrone. I've made one such of these curves. By taking a circle and rolling it about, I've made a brachistochrone curve. Now, to demonstrate this, I've made this little contraption in which I also have one of these, which is a steep acceleration and a plateau, which you would admit is probably pretty fast. And this, the straightest line from point A to point B. Let's see what it does, I guess. So, the shortest point from point A to point B is not the fastest. That's weird. That's suspicious. But the brachistochrone was the fastest. Not only that, the brachistochrone is now also what's known as a tautochrone curve, meaning that no matter where you start a ball on this curve, it will always hit as if it was at the top. The same exact time. Tauto meaning same, chrone meaning time. Let's try it out. So here, I got 3 of the exact same curves. I cut them all out the exact same way, so they should be pretty close. Now, let's see what happens. Let's watch these balls drop. Is it just me who thinks that it's awesome that there's a single curve that follows Snell's law in the same way that light refracts off of refracts off of different objects?
I literally don't care.
That also, like, adheres and takes advantage of the forces that pull an object to the ground in the best ratio possible?
Not only do I know,
isn't it cool?
I don't know what you're saying.
Isn't that crazy how that all just happens at once?
Yeah, bro, it's crazy. It's crazy.
No, just me? Okay.
No, I said it's crazy.
Thanks, bro. And no matter where you start, you could come from here, you could come from all the way down here. Doesn't matter. You all end up in the same place. Everybody wins. I kind of like that message. Yeah, it's pretty good. Are you ready to go get some Wendy's? Yeah, let's go get some Wendy's, bro.
You did it bad. I'm still recording. You gotta do it. Now, make a cool face. That's not very cool. Brachistochrone.